All right, let's talk about something pretty amazing and honestly fundamental to how all of crypto works. We're going to dive into the journey of a brand new Bitcoin node, how it wakes up for the first time and gets caught up on 15 years of history from a global network.
So let's really get into this, because it's such a cool question. I mean, think about it. This isn't just about downloading a file. It's about joining this massive, decentralized system, checking its entire history for yourself, and becoming a full-fledged, authoritative member, all without some central server holding your hand. So how on earth does it pull that off?
Well, to understand our new node's journey, we've got to meet the locals first, right? These are the established members of the network, the ones who already have the full story. They're the gatekeepers, the guardians, they are the full nodes. And here's the most important thing you got to understand about a full node. It is not a passive listener, not at all. It's an active, totally independent auditor. Its motto is, don't trust, verify. It downloads and meticulously checks every single transaction in every single block, all the way back to the very beginning, to build its own undisputed copy of the truth.
Now, our new node is about to join a pretty specific club. While there are a few different types of software you can run, the vast majority, we're talking over 95%, run Bitcoin Core. Think of it like a shared language. This common ground, this shared set of rules, is what allows this whole decentralized orchestra to play in harmony.
Okay, the stage is set. Let's start the story. Picture a computer, anywhere in the world, firing up the Bitcoin Core software for the very first time. This is the moment our new node is born.
And when I say it's born alone, I mean completely alone. It's not connected to anything yet. It has zero knowledge of the hundreds of thousands of blocks that have been mined since 2009. It knows just one thing, one single hard-coded piece of information.
This is its starting line. The only thing it knows for sure is block 0, the very first block ever created by Satoshi Nakamoto. It's statically embedded, which is just a fancy way of saying it's literally baked into the code itself. This block is its North Star, the one fixed point of truth that its whole journey is going to start from.
So, knowing it's totally out of the loop, the node has a simple first mission: find others. It has to reach out into this digital void, find some of those established peers, and basically ask, hey, what did I miss?
And this first contact is like a quick digital handshake. Our node sends out what's called a version message to introduce itself. Its peers reply with their own. And the most important piece of info they swap here is something called best height, which is basically just them asking each other, so how long is your copy of the history?
And right there, in that first handshake, our brand new node has a huge uh-oh moment. It looks at its own block height, which is 1, and then it sees its peer's height is over 800,000. That's the moment it realizes the scale of the mountain it has to climb. It's got a decade and a half of history to catch up on.
All right, now the real work starts. The node kicks off this two-phase process called initial block download. You can think of it as a highly optimized, super-focused sprint to download, verify, and piece together the entire history of Bitcoin, as fast as as fast as computationally possible.
You know, the best way to think about this is like you're trying to build a giant library from scratch. You wouldn't just start randomly shipping heavy books, right? No. First, you'd get the library's index, a list of all the chapters. That's what block headers are. They're these lightweight summaries that prove the whole history exists and that it's in the right order. Only then do you start requesting the actual books, the full blocks.
And this whole process is super strategic. First, it grabs those headers, that index, in big chunks, like 2,000 at a time. That's phase 1. Once it has a good roadmap, it kicks off phase 2. It starts asking for the actual full blocks, but it does it in parallel. And as each block, each chapter comes in, it immediately validates it to make sure it follows all the rules and adds it to its own growing bookshelf.
And this is where it gets really smart. It doesn't just ask one friend for the entire library. That would be crazy slow. Instead, it connects to a bunch of peers and asks for different books from each of them, all at the same time. It's piecing the history together like a giant decentralized jigsaw puzzle. And to manage this absolute flood of incoming information, the node keeps a download queue. At any given moment, it has up to 1,024 blocks lined up, all waiting to be processed. It's this massive, coordinated effort to rebuild history as fast as it possibly can.
You know, this brings up a really important question, doesn't it? The node has to get the blocks in perfect order to check them. So what happens if it's waiting on block number 100,000 from a peer with a really slow connection, but it's already received all the blocks up to 100,500 from faster peers? Does the whole assembly line just grind to a halt?
The answer is a hard no. The Bitcoin node is, and I'm not exaggerating, absolutely ruthless in its mission. If the one specific block it needs right now doesn't show up quickly, it does not wait around. It instantly drops the connection to that slowpoke peer and just asks someone else for the missing piece. The mission to sync is just too important to be held up by anyone.
So, after hours, maybe even days of this relentless downloading and validating, our node finally gets the very last block. It's caught up. It made it. So, what was the point of all that? Why does this whole epic journey matter so much?
By going through this whole process, our node has completely transformed. It's no longer a student, learning the history from others. It is now a master. It holds its own complete, independently verified copy of the entire ledger. It has become fully sovereign. And that means it never has to ask for permission or trust anyone else's version of the truth ever again. Its copy is the truth.
And this new status comes with some serious power. It can now check any transaction or block for itself, which is just worlds away from traditional finances, where you have to blindly trust that a bank's private ledger is correct. Our node also makes the entire network stronger by helping enforce the rules and passing along valid data to others. It's graduated from being a data taker to a gatekeeper.
So, I'll leave you with this thought. This journey of a single node, yeah, it might seem super technical, but what it really represents is a pretty revolutionary idea. In a digital world where we're relying more and more on big, centralized companies to tell us what's true, what is the real power of a system where anyone at all, can run this software, complete this journey, and verify everything for themselves? That's what this is all about.